Since this webinar is a part of IEEE PES Day celebration, let's get some idea regarding PES. PES stands for Power and Energy Society. This IEEE Power and Energy Society Bangladesh chapter is a part of IEEE and leads various programs of electrical and power energy systems in Bangladesh. The Power Engineering Society was rebranded into Power and Energy Society on 22nd April 2008 to focus on helping the environment and the society. This day has been officially commemorated as PES Day for last 3 years. This year, the theme for the 4th PES Day taking place is Clean Energy Revolution, and the main goal of this year's PES Day is more power to the future with clean energy revolution. 𝗥𝗲𝗀𝗿𝗆𝗍, Vice Chair of IEEE WIE Affinity Group, and Siraja Munira, Program Coordinator, have been assigned as Campus Ambassador in WIE and WIP category and Student Branch category, respectively, from our institution as a part of IEEE PES Day celebration. Research units in power and energy sector with data and artificial intelligence. As the title implies, we are looking forward to having insights about coordinating data with power and energy. As the keynote speaker today, we have someone who has got a bag of experience of more than 2 decades in the education and industry sector. She has been the chapter representative of IEEE PES RTN West and also chair of IEEE PES India Chapter Council. As a recognition of her sincere efforts, she was awarded the Outstanding Volunteer Award by IEEE India Council 2020. And she is none other than Dr. 𝗤𝗲𝗀𝗿𝗆𝗍𝗂, our today's guest. Before starting today's proceedings, we would like to introduce our esteemed guest of today's event. We have Dr. Mohammad Mushfiqul Haque sir, who is the advisor of IEEE Student Branch and also the professor in the Department of Computer Science Engineering, 𝗓𝗏𝗄𝗏, who is also the director of 𝗘𝗶𝗄𝗏 IT Business Incubator in 𝗓𝗏𝗄𝗏 and also the director of Student Welfare in 𝗓𝗏𝗄𝗏. Today we also have Lamia Alam ma'am, who is the advisor of IEEE 𝗓𝗏𝗄𝗏 WIE Affinity Group and also assistant professor at Department of Computer Science and Engineering at Chittagong University of Engineering and Technology. I would like to express gratitude to the guests for joining the event. Let's hear some words of wisdom from our esteemed guest today. Firstly, we would like to hear from Mr. Mohammad Mushfiqul Haque sir. Mushfiqul Haque sir, over to you.
This territory and the mission of the university as well.
Okay, thank you so much. Can you hear me?
Yes, sir, we can hear you.
Okay, sorry. Actually, I have another program with Bangladesh section chair. So I would like to thank our honorable speaker, Dr. 𝗤𝗲𝗀𝗏𝗍𝗂, chair PES India Chapter Council, for having with us. And we are very grateful to join our program to encourage our student and IEEE volunteer who are working in the 𝗓𝗏𝗄𝗏 IEEE student branch. So nowadays we actually know that the AI is the emerging technology in all the field, not only in the computing and also the power sector. There is the enormous probability of using the AI, especially in the energy market. So there may be the critical impact as clean, cheap, and reliable energy is essential for the developing countries. So there is a enormous challenge to manage the power efficiency, and there is maybe some balance between the demand and supply. So AI and big data analysis may be used for the efficient use of power energy and transparency in the power sector. So today the topic is research opportunities in power and energy sector with data and AI. So I think our honorable speaker highlight the key points in this topic, and our student is benefited from her speech. So there's the enormous possibility nowadays to use the AI, for example, the smart grid and IoT devices, smart meter, and so many other possibility to use the AI and big data in energy sector. So I request every member or every participant in this program to please join at the end of the program, so you may find a useful insight from our honorable speaker. So I thank you, the volunteer of the 𝗦𝗃𝗀𝗃 student branch, for organizing such a wonderful event and to manage such a wonderful world-renowned speaker to this program. So I wish a grand success of this program. Thank you so much. So I have another program, so if you permit, so I will leave the program and maybe join.
Thank you, Dr. Hao. Thank you so much.
Thank you, ma'am.
See you around. Thank you.
Thank you so much, Moshul sir. And now we have our esteemed teacher and also the advisor of IEEE to its student branch. We have Ms. Lamia ma'am. So now we will be moving on to Lamia ma'am to hear some words of wisdom. Lamia ma'am.
Thank you, 𝗥𝗲𝗀𝗃. I hope I am audible.
Yes, ma'am. You're audible.
Assalamu alaikum, everyone. Topic of today's webinar is research opportunities in power and energy sector with data and artificial intelligence. This webinar is hosted as a part of celebrating IEEE PES Day. It's a pleasure for us to have Dr. 𝗤𝗲𝗃𝗿𝗆 as a speaker of this webinar. I'm really looking forward to this webinar, as I am also interested, having a CSE background, I'm also interested in artificial intelligence. So I think this webinar is going to be very interesting, not only for students who are in IEEE department, but also students who are in CSE and ET. So I hope everyone is, I know everyone is here to hear from our esteemed guests, so esteemed speaker. So that's all from my side. Thank you.
Thank you, Lamia ma'am. So now we will be moving on to the webinar. Before starting the session, I would like to tell all the participants to feel free about interacting in the best possible way. You can drop your queries in the chat box. Also, at the end of the session, you can turn your video on and share your queries with our esteemed guests. Also, you will receive a feedback form at the back end of this session. Please remember to fill that up. On the topic of research opportunities in power and energy sector with data and artificial intelligence, we would like to hear from our guest, Dr. 𝗤𝗲𝗃𝗿𝗆 ma'am. Over to you, Dr. 𝗤𝗲𝗃𝗿𝗆 ma'am.
Thank you, 𝗥𝗲𝗃𝗃. Thank you so much. Now, let me share my screen and let me get inputs from you, whether screen is visible and the slide is visible. Just a minute. Once it is there on your screen, let me know.
Yes, ma'am,
so
the
that
slides are visible now.
Okay. Only one request is like, in meanwhile, while delivering this particular speech and sharing my experience so far of using data analytics and artificial intelligence in power and energy domain, anytime if you feel that there is an interruption or there is a kind of pause, you have my number, so you can directly call me, because normally when we deliver such things, we really do not understand if there is sort of an interruption that happens with the network connectivity. So that's my very genuine request to the organizing team. So let's officially start with this particular webinar. Good morning to one and all. And I'm very hopeful that all of you are keeping well and doing great. Let me wish you great PES year and great IEEE activity year for 2021. Let me take this opportunity to thank my very dear friend, Dr. Celia, who is very active volunteer, who is very active IEEE leader, and also Dr. Fatah for giving me this particular opportunity to share my experience with the student community as well as faculty members. Of course, at the outset, I'm thankful to Dr. Hauk and Ms. Lamia ma'am, Angona, an entire team of IEEE Affinity Group Student Branch of CUET Bangladesh. So thank you very much for giving this opportunity. Let's have an interactive session. I'll be more than happy to ask your questions, queries, or if you would like to know something more from me. Now, as per the topic which I have selected, the content of topic is concerned, I would like to talk about smart grid. I would like to talk about the humongous, enormous data that we generate in smart grid at every instant, because we deal with electricity, which is a live commodity. So when we are in the era of generating huge, enormous, large amount of data with the help of advanced metering infrastructure, the time has come that we must be in a position to very actively leverage this particular data, apply AI algorithms so that we will understand the context of data and we will make it more useful to all power system engineers who are working in utility value chain, that is generation sector, transmission sector, distribution sector, and even energy market, because we know that entire world actually, we are in this particular era of restructured and deregulated power sector scenario. So we have smart grid, we have all these digital enablers helping us to make our grid more visible, to control this particular grid, to work with more efficiency, more accuracy, more reliability, and get more resiliency. So if you see this particular slide, this is a kind of a real-time picture, what we see in command and control stations all over the part of world, where engineers wish to monitor and observe the real-time power grid. Now, of course, though the topic which is selected is about research opportunities, rather than just pinpointing about the domains, I thought, let me give you examples of different domains where actually, we can demonstrate the use of data analytics and artificial intelligence. And then for the matter, of course, I will be giving you a little introduction about data analytics and artificial intelligence, and then we will move on in understanding better and better about how these two tools will be useful to us. So now this is what is the picture which we see in every command and control signal. And this picture is nothing but making us understand the real situation of the grid, real situation of power system. When we say real system, it means we get real, dynamic situation of power system from the point of view of active power flow, reactive power flow, voltage values at substations, power frequency at every substation. So we get to know the real-time information using this advanced metering infrastructure. We can call this information coming to us in terms of numbers. So we can call that as data. Yes. So if you see this particular slide, this speaks about two important components these days. Because of calling ourselves as smart, these two components are, one is data and second one is, say, communication. Now, as far data is concerned, basically we get this huge information coming from every corner of our system, which actually gives us real picture of system, real picture of phenomena, real picture of operation of transformer, transmission line, then switchgear, every device and equipment which is present in power sector. So data resides, or what it has information, it has knowledge about the real picture of the system. Second is, say, communication. So on one hand, there is data. On second hand, you have to have a proper communication so that we will be in a position to complete closed loop system of control actions, so that indicative control strategic action plan will be ready for power system engineer to take up decisions on what action he has to perform at particular instant of instability, at particular instant of failure of any device, and so forth. So if you see this picture, this is a representative of PMU, that is phasor measurement unit, that where these units we install as a measuring instrument at various locations of our system. And then what it does, it basically fetches data, fetches information, fetches all important values or parameters of our system simultaneously from every corner of our system, or say power sector. So then we are ready with huge type, variety of data, I should say. Now, what is this variety that we have with us? This variety basically encircles different power system parameters, as already I mentioned: active power, reactive power, voltage value, frequency. Along with system parameters, we get other information like, see, on and off status of switch gear. We also get other information of trend of overloading of the assets or trend of overloading of the power system equipments. We also get information about penetration of renewable energy into real grid. Now, when we say this penetration of renewable energy is also going to be very, very important DER source of generation to balance load demand. And that's why as our DER comes along with its inherent property of being intermittent, monitoring, observing, forecasting becomes an imperative action for every utility. Along with these system parameters, we also get to know information about power quality attributes. Now we know that here economics of power generation is important. Economics of power sector operation is very important. So along with, say, economic operation, along with optimum operation, along with reliability, or say reliable operation, another segment which is important is quality operation. That's why we want these power system parameters to be as per the specifications, and there should be minimal power quality attributes, violation of power quality attribute that should have, that is expected to happen in grid. So when you say that we are so much equipped with these smart technologies and smart metering infrastructure, if we do not use smartly the presence of these infrastructure, then there is no point in saying that we do live in smart grid. So now, after getting this variety of data, then comes a question to our mind that anyways, how we are going to make use of this data. So are there technical tasks? Are there technical challenges? Are there technical requirements for which this data is useful? So see, here there are a couple of examples how we can leverage this particular data where knowledge is presided to perform optimally few operational tasks in power sector. Now, the example which are quoted on this particular slide, they talk of fax devices. Here there is another example of online tap changing of transformer, so as to keep power system parameters within the limit. There is another real-time example of automatic generation control, because generation load balancing is key factor of keeping system in stable condition, and that's why continuous chasing of load, continuous generating active power to fulfill load, keeping frequency within the limit is something which comes under automatic generation control. That's a control strategy where normally we use proportional plus integral controller. Even load curtailment, load engagement, load variation is another task where you would like to encourage customer also to become part of real-time generation load balancing. And of course, islanding. If you know something about islanding, then that's a kind of a very last stage decision normally been taken up so as to isolate parts of system from each other, avoiding perturbation effect to the entire system and resulting into cascade tripping of a power system and resulting into complete blackout in a way. So now once we know that yes, there are sources of data. Data has got abundance of knowledge, and then we really need to make use of this data to perform so many operational tasks in power system. Then comes a question of this data analytics as a tool. That what is the meaning of data analytics? What do we do in data analytics? So the title itself is in a way self-explanatory to understand that we would like to analyze this information and knowledge which is present in the numbers or say trends or say variations which we get from metering infrastructure. So basically understanding this information which is present in data is first prime objective of data analytics. Then what we need to do, we need to identify and analyze the behavior of system through understanding this particular data. And ultimate aim of this is to basically draw some conclusions, draw some inferences, draw some insights from understanding this data so that we can take up required corrective actions. So in short, what comes under data analytics is primarily classification and clustering. So this is just a kind of an example that when we deal with even voltage as power system parameter, we definitely can club or rather disintegrate voltage magnitudes in terms of actual standard voltage, over voltage domain, then under voltage segment. And then here itself you can have 3 clusters. So what normally we need to do while understanding the stable stable variation in the value of voltage also, you can simply classify them and cluster them into groups. So now this is something like there are 5 clusters, and when any new entry comes into this, then we try to identify, first whether it's going to get classified into this cluster or this particular cluster. So that way classification and clustering as a part of operation happens in a sequential manner. Now, understanding more about analytics, here there is a kind of 4 types of analytics tasks which a power system engineer can perform. Starting with descriptive analytics, moving towards prescriptive analytics. Now, what this graph describes, it basically describes the complexity of tasks and the need of analytics to be performed on the data that we get. So here when we start with a very simple problem, like if there is any failure of equipment or an asset, then in that case, by to know what has happened, the way we analyze what has happened comes under descriptive analytics. This is very important. When you people will complete your graduation and join any utility, probably you would be handling some 10,000s of transformer under you. And then in that case, it would be very important for you to understand, dig out the description which is already mentioned in the logbooks also, to know out of 10,000 which are those transformers which do have a tendency of getting overloaded to the extent of calling some sort of failure. So descriptive analytics helps you to understand what has happened. Going ahead to diagnostic analytics, diagnostic analytics helps the engineer to undergo the diagnosis of understanding why that failure has happened. Now, knowing what has happened, reasoning out why that has happened, of course, we would like to know the likelihood of same happening in future so that we can plan before that thing happens and preventive measure to avoid the occurrence of failure. So here there comes the 3rd type of analytics, which is predictive analytics, which helps you to predict the behavior of system, behavior of equipment. Say, for example, in understanding whether what is the chance of failure of that, say, transmission line, or what's the chance of failure of transformer, what's the chance of malfunctioning of circuit breaker. So likelihood gets assessed and evaluated in predictive analytics. And then comes prescriptive analytics. So prescriptive analytics is a kind of an action plan to be handed over to that engineer to be ready with his actions as and when any event happens. So that is the kind of a value chain, which is present in analytics domain. Now let's see in a very simple language, what exactly is the interpretation and meaning of artificial intelligence from our perspective, say from electrical engineering perspective, from core engineering perspective. So basically there are two terms which we can see here. One is artificial and second one is intelligence. Now, simple meaning of artificial is like anything which is not naturally present is artificial. So in other words, we can say anything which is man-made can be considered as artificial. Now, this artificial word is clubbed with intelligence in this case. Now, intelligence is a qualitative attribute which speaks about so many characteristics of behavioral, say, strengths. Now, what are these behavioral strengths which are inherently present in live beings? Now, these inherently present behavioral strengths are our ability to think, our ability to reason out, our ability to understand, our ability to apply some logical thought process. Now, all these are our inherent characteristics, which we call as intelligence. And then when we write a software, when we write a code to embody such sort of abilities to that software, to make it to be in a position to become adaptive, to become progressive, to become predictive, to become logical in nature, we can combine that entire process as an artificially intelligent developed tool. So there is a branch of knowledge engineering which takes care of knowledge, segregating information which is hidden in that data in terms of knowledge, extract that knowledge, build software codes to make machine think, apply logic and come up with some sort of inferences. Now, as I said, though I wish to share with you research opportunities, I wish to share these opportunities in terms of demonstrative cases. So these are 4 demonstrative cases I wish to discuss with you to give you insights about different opportunities where you have to apply data analytics and say AI. And intentionally, I have considered different segments of power and energy sector, starting with say power trading market, then DER integration, which comes at distribution sector. So as far as power trading market is concerned, it's an independent system operator which operates at, say, transmission level at power sector. DER is somewhere we belong to at distribution sector. Now, asset management is a kind of value chain which is present starting from generation to the distribution end. And we all are aware of huge adaptive embracement towards electric vehicles. So let's even touch upon what great work you can do in electric vehicle segment. Now, just to give you a demonstration of this task of price forecasting, which is predictive analytics, I've taken a case study of Indian Energy Exchange. Along with Indian Energy Exchange, we have also explored other international markets like California market, Nordic pool market, EJM market, Australian market. And along with these 4-5, we've also discussed about how you will be in a position to apply artificial intelligence tools for predicting price of power. Now, I hope you people are aware of power trading market. If I give you example of Indian Energy Exchange, then in India, power trading market is started in 2008. So in and around, see, this is quite a mature market working very successfully for more than a decade. And then market clearing price is that differentiator, key volatile parameter, which we really need to predict because there are so many operational techno-commercial decisions of the utilities and even ISO. These decisions are dependent on knowing accurate price of power. And that's why that is a kind of a thrust area we should look at it, and we should develop these tools to predict market clearing price with apex accuracy. And then knowing that this is useful for so many tasks, here I have given one example to demonstrate how we can use it. Now, simple, straightforward, very simple starting point for this particular study is like, we really need to group number of days available with us and number of, months available with us to deal with the data that is again available with us. in short, so when we, in a very simple, language, I can explain that what we have again large amount of data. Like every day, we have 365 days. 365 days multiplied by 24 market clearing price will be the kind of database available with you for a year. In the same way, if I wish to utilize historical information of last 3 years data to understand trend of change of market clearing price in Indian Energy Exchange, you can understand scaling up of this particular data. Now, what is our task? Our task is to forecast tomorrow's market clearing price. So when we say tomorrow, this tomorrow can be any day, like Monday, Tuesday, Wednesday, or it can be of any month, like Jan, May, December. But the power system engineer must develop a model to forecast price of power of every day, every hour, every month. Okay, so that is what is the task. And for that matter, very simple but robust way is like develop 12 neural networks. Okay, every neural network dedicated for every month will take care of price volatility and price prediction of every month. But that's not a wise decision. Developing 12 neural network is really not advisable. On the contrary, you should understand, having these tools with us, check the similarities, check the map, map these database with each other and understand how much is the coherence that exists between these values, to map them in terms of categories, so that rather than developing 12 neural networks, come to a conclusion of optimum number of development of neural networks for forecasting price of power. Okay, so with this task, we started with our work. Here, the first task was to cluster cluster the days based on their behavior. Second, cluster months, and then club them together to finalize how many total number of neural networks you have to develop. Okay, so now in this case, this entire work is done in our language, and the data analytics tools which we have used, they are K-means technique and KNN technique. Now there is a prescribed rule that before applying K-means technique or say KNN technique, we need to first formulate number of clusters, okay, as a rough hand thumb rule. Because when you are dealing with say 20,000 number of samples, you should know tentatively these 20,000 number of samples should get clustered into 3 number of groups or say 5 number of clusters, like this, So there are again couple of methods which give you this indicative, preliminary, tentative number of clusters as guideline to go ahead. So here there is one method which is called as elbow method. So using this elbow method, what we understand ultimately, see, I am excluding mathematics part, I'm excluding algorithm, and I'm excluding programming parts thoughtfully out of this particular discussion. Let's understand the outcome. Outcome is like when we use this elbow method, simply what it help us to know, optimum number of clusters, okay, for given database. So here handling 20,000 samples as per the elbow method, 3 number of clusters are sufficient. The logic of this deciding this number of clusters is like when the error starts minimizing, from that point, pick up the point. So now this is that point or the elbow from where error is it started minimizing. So here elbow says that let's go ahead with 3 number of clusters. We wanted to cross-check even this tentative suggestion of 3 number of clusters. So we used NB-clust method. So this is another method which again applies its own rules and regulations to decide how many number of clusters are optimum for the given database. Okay, so knowing so many indices, the one which gives you highest number you should pick up. So in this case also, 3 number of clusters comes out to be an outcome of NB-clust method. Okay, so now we got this confirmation that let's apply, K-means clustering method to this particular huge database and then divide this database into 3 clusters. At this moment, we do not know who is going to fall in these clusters. We only know that there are going to be 3 clusters. Okay, and that's why here we use k-means clustering method. Let me explain the meaning of this K. K stands for cluster and mean stands for calculation of mean of values which are close to the centroid. So again, it has its own algorithm which we should follow, logic we should follow. Build the program in Python. Actually, here we use Python for writing code for k-means. Now, the outcome of this k-means says that out of 7 days, if you see this table, you will realize that out of 7 days, the behavior of first 3 days was so similar to each other that Monday, Tuesday, and Wednesday fall in cluster number 1. The price variations of Thursday and Friday, they were so similar to each other, having good coherence, that these prices behaving similar, you can make these 2 days to come under one group, that is our second group. And in the same way, Saturday, Sunday behavior, of course, the behavior of market clearing price is found to be cohesive to each other, and then we form third cluster consisting of Saturdays and Sundays. Okay, so now in this particular way, we have clustered 7 days into 3 groups, 3 clusters. Now, the first task is done, like grouping of days into clusters. Now there is second task. Second task is to group 12 months into clusters. Now for this case, what we did, we use box plot in R to understand distribution of values of market clearing price. So let me see what to extract from this particular box plot. If you see this particular box plot and the distribution of market clearing price, which actually talks about mean value, then first quartile value, third quartile value, and the distribution of values in terms of say probability distribution, in other words. So now here, if you observe from 4th month till 12th month, as well as January, here you will find the what you can say grouping of values being close to this average value, mean value. What does that mean? It means that here, yes, January and April to December, these months can be grouped into one cluster, and February as well as March can get grouped into another cluster. So now see here, 12 months got clustered into only 2 groups. One is the group of February and March, and second is the group of all remaining 10 months. So you never know, though you are dealing with 12 months here, still it got into 2 groups. On the contrary, though we were dealing with 7 days, those 7 days got clubbed into 3 groups. So now what we have types of types of days, and we have types of months. Now we need to combine them so that we will be in a position to develop neural network for total 6 groups, which will take care of every hour of every day of every month, completing entire year. So here we develop artificial neural network. Again, we really need to understand the architecture of artificial neural network, the learning algorithm of artificial neural network, whether this task is going to be supervised or unsupervised. So as price forecasting is a task of supervised learning, we have used feed-forward neural network and optimization technique of error minimization by error backpropagation algorithm. Here we get 24. The same logic is very simple. The applied logic is like, give today's 24 values to the network and let it predict tomorrow's 24 values of market clearing price. So we kept the number of neurons, the minimum, like 24 number of neurons in the input layer and 24 number of neurons in the output layer. And then, of course, training of neural network started, keeping 1 neuron in the hidden layer. And of course, Then people who are conversant with developing ANN, they know how exhaustive the work is as per training of neural network is concerned. So the ultimate final result is there on this particular screen, which talks of trend of minimization of error of developing neural network during the developing stage of neural network. This error curve is very, very important for a developer like us who is developing neural network for any predictive task or any task, to that matter of fact. Now check here, what does this mean? Just to explain the physical relevance of this error curve with what exactly happens during training of neural network, here is this particular graphical representation. Now what it explains, it explains how iteration by iteration there is minimization of error. Say for example, you are here at the starting point of initialization of all the weights values very randomly in the given architecture. And then what we do, we can, as per the supervised learning algorithm, we evaluate and we update the weights. While updating the weights, every iteration, epoch-wise, iteration by iteration, there is marching of this particular error getting minimized and going towards global minimum. So important is like you need to reach to the global minimum point so that the training is perfect, understanding of neural network is perfect, mapping of input output is so correct that it has understood the non-linear relationship between input sets and output sets. This is what is the meaning of this particular error surface. And finally, what we get, once we achieve the global minimum, we get the optimum set of weights, which has understood the relationship and which can get deployed in real power system to get used for futuristic market clearing price forecasting. Now, this is another curve. Just for the sake of more explanation, I have included these particular curves. Now, this is something very important that you should understand, that here, this is a typical observation. Many of the times people get when they train neural network, that network stops learning. It gets entrapped into local minimum somewhere, and then training or learning is completely stopped. It means there is no improvement in the performance of that network for large number of epochs. And this is a very alarming indication to the person who is developing neural network to take cognizance of this behavior and take corrective actions. That's one of the reasons these tools are artificially developed tools. Don't forget that word, artificial. We are the one who should take complete core responsibility of performance of the neural network. This is also another behavior of network which has got trapped into local minimum. Now let's get the outcome of this. Outcome is something like we want to predict market clearing price of next day. So what we did after developing the network, all those set of samples which we were never used for training and testing, they used for validation purpose, and then we predicted market clearing price using the network. Now if you see this graphical, from table we never understand the trend of change of all these values. Don't forget guys, we deal with time series parameters, means all parameters or majorly, I should say majorly, majority of the parameters of power sector, they are time series parameters. It means value varies as a function of time and it has got relation with time. So here also, these 24 values of market clearing price, they are outcome of n number of factors, by the way. So one of the factor is time of that particular day. That's why graph, when we plot, we actually understand the random behavior in the market clearing price and the ability of neural network to chase the randomness and correctly follow the trend of change of values. Okay, this is very important observation that one has to get when they develop neural network. And the quantitative attribute of evaluating performance of network is calculate error. It's very simple. You have to calculate prediction error. Now being time series, here when you predict 24 values, you are going to get 24 error values at every hour. So first what you do, you calculate absolute percentage error at every hour and then calculate mean absolute percentage error at the end of a day to comment on the predictive ability of the neural network. Now for this particular sample, we got predictive MAP, that is mean absolute percentage error, to be 3.14%. And the other statistical attribute or other statistical parameter which will help you to get that confidence of correctness of your model is by correlation coefficient. So when correlation coefficient is close to 1, it's a very clear cut indication of correct training of neural network, because it has ability to chase this variation also. So now for this particular sample, it has given a correlation coefficient of say 98%. Now, as per development of network is concerned, see, up till now, whatever I spoke, we have made mix of languages like R, then Python, but as per neural network portion is concerned, we have used MATLAB. So being power system engineer, I am very sure that you people are conversant with MATLAB. You must be conversant with 𝗏𝗏, ETAB, EMTDC, and other simulation software. Simulation software is a backbone of understanding electrical engineering. So do give proper weightage to the simulation software, understand the simulations to understand system better. So now once we predict, once we develop neural network to predict a market clearing price, these are various ways by which actually market traders and players who are involved in trading of power, they use this for these many different purposes. So out of this, I can demonstrate one application that is for congestion management. Now, again, you people really need to learn and study about restructuring of power sector, deregulation of power sector, congestion management of power section, then transmission congestion, market splitting strategies, risk assessment, risk hedging, portfolio analysis, everything which comes under the segment of power trading, where predictive analytics is very, very important. Simple way to explain congestion management is the transmission line corridors, choking up of transmission line corridors. Then in that case, the available transfer capacity is more than threshold. When it crosses that particular threshold, we really need to understand its effect on market clearing price and take up the decision of splitting actions. Okay, and that's why then what we did, we predicted the price of power, and then we mapped with those events when congestion has happened. The very simple logic for understanding where congestion has happened or not is to cross-check whether pulsating magnitude is observed in market clearing price. It means if your price is supposed to vary between say 3 rupees per megawatt, 3 rupees per unit to say 8 rupees per unit, if it spikes to say 21 rupees per unit, then in that case, of course, that 21 is a significant indication of something going incorrect, something having some sort of a congestion in market. Okay, so what has been done for the sake of for January month, for every day, the number of events when congestion has happened, that information is available. So based on predicting the prices, mapping those prices with those congested events, we cross-check whether we are in a position to analyze and understand these occurrences accurately or not. So I'm very happy to present to you that total number of congestion events were 504. Out of 504, we could able to predict with 92% of accuracy the congestion events to the tune of 467. That was there for January month. Same is a kind of acceptable accuracy in predicting congestion events in case of February month. If you just check March also, we are also here also, that's an acceptable accuracy of around 94%. So what does that mean? It means that if your predictive model is accurate, then rest of the actions which you have to take, or rest of the action plans which you need to be ready with, they will be successful. They will be efficient, and they will be in real time useful to you. Now during COVID-19, this this is a kind of visualization. Data visualization is very important. So data visualization we need to learn as electrical engineers, because everything which is available to us, help us know our system, is through these numbers. So we really need to try to get deep dive into these numbers and try to visualize the number. If you see these two graphs, basically what it speaks about 2019 market clearing prices and 2020 market clearing prices. See, out of my interest, I did this study because I wanted to understand impact of COVID on market clearing prices. Okay, so when we did this comparison between 2019 for a few months and 2020 for a few months, here are the observations. For 2019, if you see, the range of market clearing price was about, say, 2 rupees per kilo per unit to 6 rupees per kilo unit. These are plummeted significantly. That now the range is between, check here, it is when we talk of thousands, then it means rupees per megawatt hour. Fine. So now prices have got plummeted, making the range to go from 1 to 3.5 rupees per unit. So plummetion of reduction in the market clearing price. And even if you check the time scale at which the prices used to get clustered, the entire time scale has got disturbed. The same even you can observe in case of this May month also. But when we started approaching to December, there was little bit of settlement of market clearing behavior, or say trading, market trading behavior, which I could able to say sense except price values. So market was coming back to the behavior from the standpoint of time. But of course, market did back to normal as per price variations are concerned. So this is something I did just out of my interest. Now, the first example that I gave that was about K-means technique, KNN technique. See some of additional helpful tools like box plot, then NB-cluster method, elbow method, and feed-forward neural network with error backpropagation algorithm. Now, if you check the latest trend in the architecture of neural network, we do find LSTM, that is short-term memory neural network, becoming popular to handle uncertain time series parameters like, say, wind power, wind speed, wind gust, wind direction forecasting. So now this is another example of using LSTM for wind power forecasting. See, again, in the interest of time, I won't be explaining in detail about the architecture of this particular LSTM and the learning algorithm as such, but we use LSTM exclusively whenever we really need to handle uncertain data where the randomness is more. The biggest advantage of LSTM is like it has got a forget net, a certain specific neuron which has got an ability to filter any information which is redundant, any information which is not useful for that task. So inherently, it has that capacity that after iteration by iteration, it filters out anything which is not important for that task. Okay, that's the biggest advantage of LSTM network as such. So now this program is developed in Python, following the same logic of first get the data, then normalize that data. First, physically observe that data, take out anomalous data, erroneous data, and then what you do, you get the complete data space, then divide it into train set, test set, and then appropriately select the activation function, error minimization tool, then train the model, post normalize it, and then get the actual parameters in the known range. So now this is the outcome of the exercise and a demonstration of developed LSTM neural network for predicting, here in this case, wind power. So if you check the sample cases for which neural network was developed, again, if we check correlation coefficient is that way close to 0.9. Compared to market clearing price, if you remember, the correlation coefficient was very, very close to 1. Now here it is not that much close to 1. That itself significantly alarms, gives you alert that the parameter that you are handling is more uncertain, is more random. And that's why for networks, still it is difficult to test that particular randomness and understand nonlinear relationship. But still, if you check MAP is that way acceptable value, in an acceptable range. Because in power sector, by the way, any predictive model which gives you prediction accuracy to the tune of 5%, that is much well accepted by the utilities and the stakeholders who will be using these particular tools. So now this is a kind of predictive tool which is developed for November month. Now in this case, we developed monthly models, straightforward, because the data was so random that there was no point in trying to map and match the randomness. So better way was like to develop monthly models to take care of monthly variations, seasonal variations, locational variations, and all those things. Okay, so to summarize the second demonstrative case, where there is ample of scope for all of you to do lots of proof of concepts and validation of so many different types of tools of AI in understanding how prediction accuracy gets changed. If you apply random forest method, what will be the accuracy? If you apply neural network, what will be the accuracy? If you apply, say, naive Bayesian technique, what is going to be the accuracy? For UG students, and even to the matter of fact, for PG students, even trying out on different architectures and different AI tools in using it for, say, predictive analytics itself is going to be a good, what you can say, it will give you a good hands-on, I should say, hands-on, which will be useful for you to market yourself when you will go for either your job or say self-employment. Now, do I have time, by the way, so that I can take up this other two applications? Well, what is the advice of the organizer? Let me know. Let me get. Hello? Shall I go ahead?
Yes, ma'am.
Okay, quickly now, in the interest of time, let me quickly touch upon this asset management concept, which is very, very important. Now, we all are aware that, number of assets which we handle, they are large in number, and even they are large in variety. Like we deal with the transformer, we deal with induction motor, we deal with transmission line, we deal with underground cables, we deal with switchgear, we deal with substations at different voltage levels. And that's why here every asset is important for continuity of operation, for continuity of power flow. And that's one of the reasons that what we need to do, we really need to apply this advanced metering infrastructure. We have SCADA, which is very well mature technology. Okay, this is not at all a new thing, we are very much conversant with phasor measurement unit. We are conversant with SCADA. We are conversant with smart metering infrastructure. We are getting acquainted to IoT. And of course, now we get huge amount of data from sensors. Like, say, for example, in case of a transmission line monitoring, many distribution utilities, and even for substation monitoring, many distribution utilities, they have installed thermal imaging cameras. So these thermal imaging cameras, they click photos, and then the photos get collected at the command and control signal, where they need to process these images. Applying image processing techniques, they need to extract the features of behavior of these equipments, and then after analyzing this information, you need to project healthy, ill-healthy, progressive, predictive behavior on a dashboard, which is remotely present at various substations, so that engineer or an operator who is observing all these assets will be in a position to know whether these assets are in a safe mode of operation at this particular moment, and what is the trend that's happening with these equipments and assets. And that's why data collection, data, say, processing, data analysis, and then in taking out insights from this analytics, that is very important, because in taking out insights is responsibility of an core engineer who is aware of something what is called as stable, something what is called as unstable, something as is called as failure prone, something as is that is what is called as healthy. And that's why the role of power system engineer or electrical engineer is very, very crucial when we deal with all these assets and system integration and system stability, everything. I hope you understand your own worth and value in this particular segment of power and energy. So here itself, again, there is a huge amount of scope for you to build on data, build on analytics tool, and important part is draw insights from those analytics outcomes, which will be useful to the power system engineer. Of course, in this bunch, these days utilities, they use AR, VR, augmented reality, virtual reality, digital twins to understand internally how these devices, they will, they function under overload situation, and how with increase in overloading, what are the components, what are different parts inside that equipment will get overstressed, resulting into any sort of internal failure or so forth, so far. Now, this is another important segment for us to definitely pitch into and deep dive into and do lots of work in this e-mobility sector, because for e-mobility, if you see this slide, every bit of piece which is mentioned results and generates huge amount of data, huge amount of knowledge from the point of view of electric vehicle itself. And that's why, the data that we get from vehicle individually is different than the data which is required for a smart grid for electric vehicle perspective. The data which is required and coming from charging station gets leveraged in a very different way. So please understand that these all are different data sources, as well as these are the sources where we need to contextualize that data and develop analytics and insights to be useful for all the stakeholders of EV segment as such. So who are the stakeholders of the EV segment? See, EV owner is the major stakeholder of EV segment. Electric vehicle owner, distribution company, the geographic location where this EV owners they stay, then the marketplace, the manufacturing industry of EV segment, all they are important stakeholders. And then there is huge scope and potential for us to understand the fast growing trend of EV from two aspects. One, from individual vehicular technology aspect, and second, from the aspect of integration of EV to grid. Obviously, you're not going to connect EV at HV side at, what you can say, high voltage segment of a transmission sector. Obviously, you will be connecting this EV at distribution, secondary distribution level of power sector. Though you are connecting at secondary level of power sector, still you are going to, you may create a perturbation or a turbulence to the distribution voltage parameters, to the distribution power flow, to the distribution frequency profile. And that's why when we connect EV to the grid, again, there are so many important technical aspects we really need to study and validate and cross-check and analyze. Similarly, from electric vehicle point of view, making your electric vehicle fulfilling your requirement of a long run, you really need to monitor your own vehicle, your battery status of the vehicle, and you should be in a position to get handy signals, handy inputs or status of battery of your vehicle, at how much of, after how much of run it's going to discharge to what percentage, all these sort of important insights with respect to electric vehicles. So battery management system is very important concern for every stakeholder pertaining to e-mobility. So there is, as I said, we can do great amount of work over here. Now, another segment I thought I must introduce to you is about energy management system. Now, energy management system at grid level, at transmission level, is owned by transmission utilities. And the kind of task which they have to perform, they are different compared to energy management system, which we deal with at distribution sector. But do not forget that there is energy management system required at transmission level, and there is energy management system which is much required at a granular, restructured scene at distribution segment as well as prosumer. You must have heard of a prosumer. I'll just touch upon that in next slide. So now here, if you see, as per energy management system of grid is concerned, then that grid operator, transmission utilities, they really need to have a bird view eye on entire system and the task which they have to perform. They have to perform task of load flow, generation load balancing, then keeping entire system in stable operating mode. And then as and when whatever is required, they have to undergo that as a part of energy management system. Now, as per energy management system at, say, community level, distribution sector, or even at home segment is concerned, we are aware of home automation. So honestly, when we talk of home automation, that's the simple example, simplest day-to-day life example of energy management system of a house, where there is integration of different devices. You understand the operation of every device, the time of operation of every device, the energy consumption of every device, the requirement of energy consumption of entire home, and then map it with the tariff, understand the scope of energy conservation, tap it with, again, the kind of dealing minimal, objectives of minimization of your bill is concerned. You can aim towards using efficiently energy management system in minimization of your bill, maximizing the usage, but still keeping eye on energy conservation. And now if you are a prosumer, so prosumer is a category of a customer who has solar PV installed so that they themselves generate power from solar PV installed at the rooftop. So a customer may need power from grid or say distribution company, customer may take power from retailer, or customer himself can generate power from his own generating plant. So now in that case, he is customer as well as he is producer also. We call that category as a prosumer. So the moment you have customers who have solar PV installed, then the dynamicity increases. Distribution companies, for them, load forecasting becomes a huge challenging task because of such dynamic, uncertain injection of power from solar PV and the behavior of that customer, whether he is going to use its own power or is going to sell that power to grid or is going to take power from grid. Simultaneously, the moment you have electric vehicle, then again load forecasting is a challenging task for distribution company by knowing the charging quantity of consumption of power as well as charging patterns of all these electric vehicle owners. So now this way, at even granular level of home or say distribution sector, distribution utility sector, the forecasting and energy management, they are very, very important for us. Now, so giving you some sort of a gamut of areas where you can definitely try out working on, these are some of popular languages. As I've mentioned of the software simulation tools, they are MATLAB, then SimPower, then 𝗲𝗄𝗃, and even there are many more. Along with the same, we have to be conversant with R. We need to be conversant with the statistical toolboxes. We need to be conversant with these upcoming open source languages like, say, Python. So you have many options. Out of many options, the one which you feel you are comfortable with, you can pick up the one. But according to me, I found R that way good enough to have inbuilt modules helping us to understand data, visualize data, and plotting different ways, the same data, to draw deep dive insights from that information. So I will advise you to be more adaptive towards all these simulation tools and open source software as well as languages, so that you can be of a greater help to your own engineering community. So in short, when we need to conclude to this session, I can say that, see, the point of view of looking at core electrical engineering itself has got changed. It itself has got become wider. And that's why, along with core domain knowledge, all of us, we really need to be conversant and good at having hands-on regarding these digital enablers and digital technologies and tools of ITCS, like AI, data analytics, data science, because we generate, as a core electrical engineer, we generate a huge amount of data, and this data is just not a number for us. It consists of knowledge. It consists of knowledge of the system, which we must leverage so that we will be in a position to actively contribute to the existing smart grid. This is something I can conclude to the talk. And thank you very much for giving me this opportunity for sharing my experience so far with all of you. If you have any question, I'll be more than happy to answer the questions. So over to you, organizing team. It's if you are mute, you are on mute.
Oh, sorry. So considering the status quo of our planet now, the concept of clean energy and the need of optimizing the energy, basically empowering energy sector, is more important than ever before. And that's what we have been hearing for an hour now. So thanks to 𝗤𝗲𝗃𝗍𝗃 ma'am for her brilliant speech with so much visuals and analysis. And now we'll be moving on to our question answer session. First of all, I think we can go to the chat section and find some of the questions right there. Let me get there. The first question is from Shafin Hussain, and what he asked is that, what are the reasons for the AI to get stuck in local minimum point?
Okay, local minimum point. Now, see, understand the error surface whenever we develop AI tools is actually a very complex surface of having large number of local minima and global minimum. And of course, it is applicable to optimization task, any optimization tool. Okay, but as per AI is concerned, AI optimization is different than conventional optimization methods, like, say, for example, Lagrange multiplier technique or other optimization methods. Now here, the reason for AI or say ANN to stuck up in local minimum is incorrect sampling, which is done at the initial stage of applying database to neural network. That's why it's the prime responsibility of the person who is going to develop neural network to first understand the process, phenomena, and task technically, thoroughly, technically, so correctly that the database that we generate, the database that we use and apply for training should be very, very correct. The mapping and the dependability of input output, which we assume, when we say I should not say assume, when we decide, we need to be very sure of the input output mapping, which is decided by us for any task. Say, for example, in case of power system protection, if at all you would like to do an image processing of giving a input to any switch gear of breaking the signal, or say breaking the circuit in case of adulterated wave shape, then in that case, it's of course going to be a task of an engineer to know thoroughly well different features to be extracted from clear sine wave, transient sine wave, that wave which gets generated during failure of the kind of a sort. Okay, so the only reason why network gets tracked like this is first fundamental corrective action that one has to take is go back to the beginning, understand, and then again revise your sets and then go ahead with it. Yes.
Thank you, ma'am. So the next up, we have another question from Munira, that for a beginner in research field, how to choose the topics.
Okay, now in this case, I'll give you a very generic suggestions in this case, or a generic action plan. Very simple. If at all I want to start thinking of, just starting off my research, this very simple thing that I need to do is to check all recent IEEE transaction papers, IEEE conference papers, and of course, papers from other publishing domains also, like say elsewhere, like say Science Direct. Because first important beginning point that we should not miss is to know the current status. Normally, I have seen that people, rather than doing the current survey, they assume something and start doing their, start penetrating in anything, any domain which is already been mature enough from research point of view. So please do not, start blindly. Simple way is to attain any conference, as just an attendee also, you can attain any conference. You will understand where the trend of research going on as per system operation is concerned, as per system control is concerned, as per say advanced motors and drives is concerned, as per renewable energy sector is concerned, as per power trading market is concerned, as per electric vehicle segment is concerned. So first foremost thing is like you need to read the recent, very latest literature, and then bucket them into these sections. Like there is research going on in just now, as I said, these are straightforward 6-7 segments I see. And then out of these 6 segments, any segment which touches your heart. It's very simple like this, Nobody can make you a kind of a compulsion that you must pick up something to do work in BLDC motors and drives. Not necessary. It's up to you, your own inherent liking and inclination. Pick up that domain. So if you feel that you are you are inclined towards understanding more about renewable sector, there is ample of scope to do research in renewable. Same is applicable to protection. Same is even applicable to EV. Okay, but first foremost is read the latest. What's happening all over, irrespective of keeping your own prejudiced mind, and then deep dive, understand what is something that you started liking, understanding. Okay, and then you can then think of that as a starting point of a thread, according to me.
Thank you, ma'am.
Yes,
And
it's
we
about,
have
yes.
anonymous question from someone. Okay, and the question is that what should be the learning track for a newbie to get into AI integration and powering it? So what he or she meant is that what are the curriculums or things we need to learn for getting into this particular sector?
Okay, now in between, actually, I lost your words. So I didn't get exactly the question, but if I just match those words, what I realize is like curriculum. It's though it is not there in curriculum, what we should start with. Is that something that you were
Exactly,
asking about?
Exactly.
Okay, now see, understand, whatever is there in your curriculum is a must to learn. Okay, is a must to learn. But what is not there at the point of movement in your curriculum is these advanced tools. So there are a couple of online MOOCs courses which you can do, online certification courses which you can do. So again comes a question that what course I should do, what certification I should do. For that matter, just undergo literature review. Okay, again, try to see what is happening in IoT, what is happening in sensor technology, what is happening in AI, how data is getting used. Because data, AI, IoT, these are emerging, what you can say, emerging applications of existing systems. So there is no excuse to understanding deeply, technically, very strongly the conventional core. We have to learn it. But just you take asset management, try to learn how people are using AI algorithms for predicting the performance of transformer. If you just try to learn it, you will understand that yes, transformer is one type of asset. Likewise, parallelly, so much of work is done in, so much of requirement is there for GIS technology. Gas insulated substation. So gas insulated substation is a core domain, no doubt about it. But to understand failure of GIS, we really need to make use of Monte Carlo substation, Monte Carlo simulation, random variable simulations, and all those tools. So I personally feel that first foremost thing to begin with, just read, Google, get this information even from this IEEE transactions and conference proceedings, so that you will understand important applicable technologies and tools which are relevant to you. Okay, so the relevance is very, very important. And then you need to parallelly strengthen your own profile. Don't forget that. Okay, irrespective of having, whether it is there in your elective subjects or not, in your curriculum or not, don't be dependent on this, because these are all market driven requirements which are to be fulfilled individually as own responsibility. So my advice to all youngsters would be like, be great in your core domain, plus be great in the sense, be conversant with Python or AI tools, algorithms, though at least at the introductory phase, so that whenever we go to market, forget, it's when I talk of the market scenario, there is huge potential and huge requirement of core engineers in market. So when you say there is a huge potential and requirement, they are looking at new generation to be acquainted with these tools, by the way. Okay, they don't want you to develop AI as a new algorithm. They want you to apply existing AI algorithms. Though you wish to work in ABB or say Siemens or say Schneider or say any company as product-based one in core sector, as well as distribution companies and all these restructured private utilities, they want youth to be conversant with these tools. That is for sure. So this is how you have to equip yourself and build your profile.
Thank you, ma'am. Now, before we move on with the session, I would like to welcome one of our esteemed guests, 𝗤𝗲𝗀𝗲 ma'am, who is the professor of Department of Electrical and Electronic Engineering, KUET, and also the SWIP Art and Representative, and also the chair of IEEE Bangladesh section, Ms. 𝗤𝗲𝗀𝗲 ma'am. we would like to hear some words of wisdom from Sila Shanachman. Ma'am, over to you.
Thank you, dear student branch. Welcome, Shurekha, for your wonderful presentation. I was listening to it, and I was in another program, but using a different computer, I tried to say hello to you. How are you, Shurekha?
Thank you. Thank you so much. It's great to see you. Hope to meet you in future, you know.
Oh, for sure, for sure. We are missing. Anyway, but this lockdown situation is very worst in our country, and also I can see every day the news of India is getting, especially Mumbai, and you are near Mumbai, Pune area. So what is the situation at Pune?
No, it's very, very deteriorating, hugely deteriorating. And we have already lost number in terms of, you know, thousands a day. So the picture is really not good.
Yes,
things are
and
becoming
also in our university campus, we lost I lost my one university professor, my direct teacher, a few days ago, and also now a couple of our professors are in the COVID hospital. So let us pray for each other. This is a PACE Day celebration event. This celebration is virtually celebration of technical achievement. You know that the theme of PACE Day is clean energy revolution, and perhaps by this time you know what are the sources of clean energy. Bangladesh is the promoter of clean energy, especially solar and nuclear. Solar is renewable and nuclear is not renewable. You know it, but Bangladesh is investing a lot of funding for nuclear power energy education, nuclear power plant, and Bangladesh has created wonder in solar energy. So there are emerging areas of research, and I know India because my last foreign visit was in Delhi in 1st March 2020 for a keynote talk in conference, and I know India has also done wonder in solar energy, the renewable energy. What I would like to tell our students, utilize your power energy research. Say, I apply my deep learning techniques for power disturbance classification, for identifying an audio which is recorded near a power grid, because this is very much needed for data analytics and cyber security in power system. There are 3 emerging areas for power and energy which are controlling the future trends of power energy. One is energy storage and integration to renewables. Another is distribution generation, and finally data analytics and cyber security. So I request our student volunteers so that they can really apply and see how deep learning can be used for solar energy, because there are miles after solar panels which has been inspected by the drone, which has been inspected by the robots. So there are also wind energy that has been inspected by the drone. So these are the technology I really request our students to really look into for their emerging research, so that we can really do solar energy revolution. And not only that, it is important to use power and energy for humanitarian technology, for helping the community. A small installation of small solar panel for underprivileged school. This is very important for an underprivileged tribal community where they do not have trees, or they do not have any electricity to support freeze to preserve the insulin, or to do uninterrupted operation for the pregnant women. So these are the things I really like to encourage our students to get involved in, so that apart from publishing papers, we can support the community with our knowledge of power and energy. And it is important to become interdisciplinary. So I don't want to lengthen my speech. I really thank Dr. Shurekha for getting time to enlighten our young volunteers. Bangladesh has 43 ambassadors for PACE Day. As a section chair, I collaborated with all our PACE Day ambassadors and tried my level best to give them any support possible for knowledge dissemination. Hope Dr. Surekha will continue enlightening us also in future. Thank you, Surekha, and thank you to its student branch, especially our Women in Engineering PhD Ambassador Munira. She is so enthusiastic, and it is important to empower our PS women in power. Thank you to its student branch, and thank you, Dr.
Thank you, Dr.
Thank you so much, ma'am.
For
Thank
arranging
you. Thank you to be
this.
part of this. Yeah,
Yes.
thank you very much. See you soon.
Yeah.
Thank you, 𝗤𝗲𝗀𝗃𝗏 ma'am. It was really an amazing experience hearing from you. Before we move on, I would like to request Surekha ma'am, can you please turn your screen share off? I think that would be convenient if the technical team is working on something. Thank you, ma'am. Okay, so we are almost at the end of the session, and before we drop the curtain, I would also like to request our PhD ambassador and also the vice chair of 𝗘𝗶𝗿𝗆 affinity group, 𝗤𝗲𝗰𝗵, to say a few words.
Am I audible?
Yes, you are audible.
Okay, hello everyone. The role of PhD ambassador gave me some new experiences. I just want to thank to this honorable speaker ma'am who gave us the opportunity to learn something new to make our program a global event. And when I contacted with her, she responded so positively and rapidly. That was really great for us. I'm grateful to our Lamia ma'am, Moshul Haq sir, and obviously Celia ma'am, the chair of the section, and whenever we face any difficulties, we contact with them without any hesitation and they guide us. I believe that they will guide us in future in this way, and our entire PhD team worked diligently. So thank you all.
Thank you, 𝗤𝗲𝗃𝗏. And now we have 𝗤𝗲𝗃𝗏 Munira, who is also an ambassador for IEEE PESJ from our institution. Now moving on to 𝗤𝗲𝗃𝗏 Munira.
Thank you too for giving me slot. I would like to thank first of all the participants for making our program successful, and I would like to thanks to our student branch for the impactful support. And without our volunteering team, we cannot do as much as we can do. So thanks to you, all of you guys, and again I would like to thank Celia ma'am and obviously speaker ma'am for conducting a wonderful session. And I would like to thank Lamia ma'am and Moshul sir for helping us whenever we need them. Keep supporting us. Have a good day. Thank you so much. Thank you to all.
Thank you, 𝗤𝗲𝗃𝗏 Munira. So from our student branch and WIE affinity group, now we would like to pay a tribute to Surekha ma'am with a token of appreciation. I would like to request the technical team to show it on screen. Here you go.
This is very interesting.
Thank you, ma'am. So, thanks to the technical team for keeping it on the screen. Thank you, ma'am. And I would like to request everyone now to turn the camera on and post for the virtual gathering, since we have been doing all these virtually. Our technical team will handle the snapshot. I would like to request everyone to turn the video on and pose for the virtual gathering.
Well, dear guys, you need to excuse me because of the bandwidth issue, actually, though I have clicked on the video, it's not getting on. So anyways, the picture is there. So yeah, my presence is there on that window. I think that will work out.
Shafin, please let us know once we are done.
Thank you, Angona, for sending the invitation.
Thank you, ma'am. And hope that you will support us in this way in future.
Sure.
Angona, can you just do one thing? The screen of that appreciation certificate, can I just see that? Because I really found it very interesting. Basically, much rich with green color. Once your photos will get done, let me see that once again.
Yes, sure, ma'am, sure.
Yeah, that's perfect. Thank you. Thank you so much. Yeah, please continue.
I have taken the screenshot.
Okay, thanks to the technical team and everyone for conducting this session. It has been a pleasure hosting an event when you have speakers like Dr. Surekha ma'am. Thanks to her for the brilliant talk, which is surely going to impact everyone in the audience and inspire them to integrate data and AI with the power system and produce supreme quality research findings. Thank you so much for the effort that you put into this session and spend some of your valuable time with us. Thank you everyone from the participants list and looking forward to meet with all of you in our upcoming event. Have a great day.
Thank you. Have a great day. Stay safe, stay healthy.
Thank you so much, ma'am.
Take care. Bye.
Thank you, everyone.
See you, Dr. Sivia. See you then.